Let us now see the condition under which two rational numbers can be equal. You know that a rational number which is, let us say, 8 by 48. When I am cancelling the common factors, this is the same as writing 1 by 6. Correct, because 8 is a common factor between the numerator and the denominator. So, 8 by 48 is the same as 1 by 6. Now, suppose you have got two rational numbers p by q and a by b, and I am telling that these two rational numbers are equal. You do not know the specific values. So, what is the condition? The condition is that pull the denominators to the opposite numerator. So, you get p into b is equal to a into q. Now, where is this applicable? Let us do a sum in which this particular concept has to be used in order to solve and find the value. If 8 by minus 3 and minus p by 30 are equal, find p. So here I have written down a sum which is very basic just to show you how to apply the concept into a problem. So one main concept or one main point that you get from this particular question is that you always need to convert each and every rational number into standard form before you proceed with any word problem or any problems like this. So my question is, if 8 by minus 3 and minus p by 30 are equal, find p. So 8 by minus 3 is a rational number, but it is not in the standard form. The standard form means a negative sign should be in the numerator. So 8 by minus 3, I have written it in the standard form. Now it is said that this and this are equal. So I am equating both of them. I told you, pull the denominator to the numerator on the opposite side. So minus 240 is equal to minus 3p. 8 into 3 and 3 into p. So I will get the value of p as 80. It's a very basic sum. So it is just to, understand the concept of what you mean by the equality of rational numbers. Let us move on to the addition of rational numbers. So let us see the basic rules that need to be followed or basic steps that need to be followed when you are adding two rational numbers. Now, let us apply these steps to a problem. You have to add 15 by 25 and 3 by minus 7. So, what is the first step? Make sure each of the rational numbers are there. Make sure each of the rational numbers is in their standard form. So, 15 by 25 is not in the standard form. This is actually 3 by 5. Okay, 3 by minus 7 is also not in the standard form. This is minus 3 by 7. So now let us add 3 by 5 and minus 3 by 7 and see what we are getting. So 3 by 5 plus minus 3 by 7. Check the denominator. Take the LCM of the denominators. LCM of 7 and 5 is 35. Agreed. Now convert each of the rational number to an equivalent rational number with 35. So 3 by 5, I can write it as 3 into 7 by 5 into 7, giving me 21 by 35. And minus 3 by 7 can be written as this, minus 15 by 35. So now we are adding 21 by 35 and minus 15 by 35. Both of them have the same denominator. Now let us see what we are getting. You will get the final answer as a 6 by 35. Let us do a couple of more sums and then move on to the properties of addition of rational numbers. The first one is minus 13 by 8 and 15 by 36. So now let us convert each of the rational number into its standard form. That is our first step. Minus 13 by 8 is already in the standard form. 15 by 36, you know that 3 is a common factor. So I can write 15 by 36 as 5 into 3 by 12 into 3. Cancelling out 3, I will get it as 5 by 12. Okay. So now we are adding minus 13 by 8 and 5 by 12. Right. LCM of the denominator, you will give you 24. Right. So let us convert each of the rational number to a denominator of 24. So minus 13 by 8 is minus 13 into 3 by 8 into 3, which is minus 39 by 24. And 5 by 12 is a 5 into 2 by a 12 into 2, giving us 10 by 24. So now you are going to add minus 39 by 24 and 10 by 24, thus giving you a minus 29 by 24. You cannot reduce it any further. This is in the standard form and this is our final answer. In the case of the second sum, 31 by minus 4 has been converted to minus 31 by 4 to make it into the standard form. Minus 5 by 8 is already in the standard form. Then we are adding minus 31 by 4 and minus 5 by 8. The LCM of the denominator is an 8. So I have converted minus 31 by 4 into a rational number with a denominator 8. I get minus 62 by 8. I am adding it to minus 5 by 8, thus giving me the answer as minus 67 by 8. Now, let us discuss a few properties of the addition of rational numbers. It is the properties or the names of the properties are the same as what we did for integers or natural numbers. So, we learn closure property, commutative property, associative property and distributive property. In addition to that, we learn about the additive identity and additive inverse. Now, let us start with the closure property. If we have two rational numbers represented as a by b and c by d and we are adding them a by b plus c by d, that also will give us a rational number. So, addition of two rational numbers will always give us a rational number. So, we can say that the addition of rational numbers is closed, or the rational numbers are closed under addition. That is another way of saying it. So basically it means that whenever you are adding two rational numbers or more than two rational numbers for that matter, we always get another rational number. Okay. Now there is no theoretical proof for this. You just need to use some examples and show that this is true. Suppose I am taking 1 by 3 and 1 by 4. They are two rational numbers. I am going to add them. So you will get 7 by 12. This is also a rational number. Now, the second one is a commutative property. Now, this is something that most of the students are very comfortable with. They already know what commutative property is very thoroughly. It basically says if a by b and c by d are two rational numbers and we are adding them, a by b plus c by d will give us the same answer as c by d plus a by b. In other words, we can say that the addition of rational numbers is commutative, or you can add rational numbers in two rational numbers in any order. You will always get the same answer. Okay. Now let us check whether this is true by taking any two random rational numbers. So let us take 3 by 5 and 1 by 7. So what do you get? I take the LCM, then I take this. Okay. What do I get? I get 26 by 35. Now let me add it in the other way. I take the LCM. I again get 26 by 35. So, two rational numbers can be added in any order. You will always get the same answer. So, we can say that commutative property is being followed by rational numbers during addition. Okay. So, the third one is associative property. After commutative property, we move on to the associative property. We are talking about three rational numbers or more than three rational numbers. Let us start with three rational numbers. If a by b, c by d and e by f are three rational numbers, the answer for this will be the same as what is the meaning of the bracket here? The bracket means you need to add those two rational numbers first. So, you find out the answer for a by b and c by d, and whatever you are getting, suppose you are adding it to e by f, you will get the same answer by adding c by d and e by f first and adding it to a by b. The order in which you are adding rational numbers will not give you a different answer. you can add your rational numbers in whichever way you want. So now let us take a simple example for this particular property and show that it is true, and then we will see where this particular property can be effectively applied. I have taken three random rational numbers, 2 by 9, 3 by 7 and 1 by 5. First I have added 2 by 9 and 3 by 7, and that answer I have added to 1 by 5, thus I am getting 268 by 315. That is my LHS. Now in the RHS I am adding 3 by 7 and 1 by 5 first, and then adding 2 by 9 to it. So here you can see that is what I have done. So I am getting the same answer. So you can add any number of rational numbers in any order you want without making any mistakes. Obviously you will get the same answer. Now why is associative property important, or how are we going to apply this? You are given four rational numbers and you need to add them, and these are the four rational numbers: 1 by 8, 3 by 7, 5 by minus 8 and minus 11 by 7. You need to add them. Why are we using associative property, or why am I talking about associative property here? See, basically in associative property, what did we learn? We learned that we can add the rational numbers in any order we want, not the order in which the numbers are given in the question. So now this is going to help us, because wherever you have a common denominator, you can group those rational numbers. Okay, so here our first step is always to represent the rational numbers in the standard form. So 1 by 8, 3 by 7, negative sign in the denominator goes to the top, and here all the numbers are in the standard form. I am going to group those numbers whose denominator is the same, so I don't have to take the LCM there. So 1 by 8 and minus 5 by 8 will be grouped together, and 3 by 7 and minus 11 by 7 are grouped together. So what do we get? You get a minus 4 by 8 and minus 8 by 7. Correct? Minus 4 by 8, again if I have to represent it in the standard form, I can represent it as minus 1 by 2 and minus 8 by 7. Now reducing minus 4 by 8 to minus 1 by 2 is not mandatory. You can retain it as minus 4 by 8 and do the sum, but then when the denominator is huge, it is more difficult to take the LCM. So I am going to reduce it, bring it to the standard form and proceed with my sum. So here my LCM is a 14. I will get a minus 7 here, and and I am going to minus 16 here. Okay. So here I will get minus 23 by 14, which I cannot reduce further. So this is our final answer. So this is where actually the application of associative property is important. See, whenever we are doing the sum, we actually do not recognize. See, as and when you proceed with addition of rational numbers, mentally you start grouping these numbers, because you know that you don't have to take the LCM over there. But actually what we are doing is we are applying the associative property, because we know that regardless of the order, we are going to get the same answer. Now let us talk about additive identity and additive inverse. So what is additive identity? What's the meaning of additive identity? Whenever you are adding a number to the additive identity, you should get back the same number without any change. So basically in all the cases, whenever you are adding 0 to any number, we get the same number. There is no other number that we can add to an existing number, so that there will be no change in the answer. So if a by b is a rational number, and if you are adding 0 to it, you get back a by b. So you can say that 0 is a additive identity for rational numbers. Now let us talk about additive inverse. So what do you mean by additive inverse? Whenever I am adding additive inverse to a rational number, I should get back additive identity. Always it is the same concept, irrespective of any number system. Additive inverse basically means whenever you are adding additive inverse to an existing rational number or a whole number or anything for that matter, you should get back the additive identity, or you should get back 0. Or in simple words, additive inverse is the negative of the given number. So if a by b is a rational number, minus a by b will be the additive inverse. Or if minus 5 by 7 is a rational number, minus of minus 5 by 7, which is plus 5 by 7, will be the additive inverse, so that when I'm adding these two together, you get back 0, which is the additive identity. Okay, very basic concept and very simple too. So I hope you are very clear with this. Now, most of the sums based only under addition are very simple. So most of them are like verify the commutative property, verify the associative property, or they will be giving you a few numbers and we have to find the additive inverse, or they will ask what is the additive identity, or the sum in which 4 numbers or 5 numbers are added and you need to group the ones with the common denominator. So all this have been covered when I was explaining the sums. Now one more particular point that I would like to tell, if they are asking the additive inverse of 0, please understand 0 is neither positive nor negative. So the additive inverse of 0 is again a 0. Fine. So now let us move on to the subtraction of rational numbers. Subtraction of rational numbers. Now, subtraction of rational numbers follows the same rules as addition. What is the reason? The reason is because if I am subtracting C by D from A by B, I am basically adding the additive inverse. Correct? This is a concept that you must have learned while learning addition and subtraction of integers. So whenever you are subtracting two rational numbers, you are actually adding the additive inverse of the second number. So now it basically became addition. So how to do it? You take the LCM and you apply the equivalent fraction thingy to the numerators and find the answer. So nothing new in subtraction. So now let us do a few sums in subtraction and then move on to the properties. Subtract minus 3 by 5 from 7 by 11. So one thing that you need to be very careful is that you need to keep in mind very clearly which number you are subtracting from which number. They are not asking you to do minus 3 by 5 minus 7 by 11. They are asking you to do 7 by 11 minus 3 by 5. So here two minus signs together, it will become a plus sign. So now this became a very simple addition. So now let us take the LCM. Okay. You will be getting the answer as 68 by 55. Subtract 3 by 4 from 5 by 7. So you know that this is 5 by 7 minus 3 by 4. So since the sign in the center is staying as such, you will take the additive inverse of the second number. So this becomes 5 by 7 plus minus 3 by 4. Now this became a very basic addition. You are going to take the LCM. Fine. You will be getting minus 1 by 28. The sum of two numbers is minus 4 by 3. If one of the numbers is minus 5, find the other. These are all very common sums which come under subtraction of rational numbers. So when you are doing this sum, it is always better to write down the steps so that you do not make any mistakes. So let us take the number to be found as x. So it is given that two numbers are added, one is x, the other one is minus 5. So what is x now? Correct. Now two minus signs coming together, it is plus. Fine. So you will get the answer as like 11 by 3. What number should be subtracted from minus 8 to get 11 by 3? Again, better to write the steps so that you do not make mistakes. Let us take the number that is to be found or the number that is to be subtracted as x. So this number is subtracted from minus 8. Okay, and we are getting 11 by 3. Now let us rearrange. Let us take x to one side and the numbers to the other side. So minus 8 plus minus x. Fine. This is equal to 11 by 3. or I can say minus x is equal to 11 by 3 minus minus 8, giving you 11 by 3 plus 8. Fine. So you will get 11 plus 24, thus giving us 35 by 3 is the value of minus x. So what is the value of x? The value of x will be minus 35 by 3. I hope you are clear with this sum. We have taken the number that is to be found as x. That number was subtracted from minus 8 to get 11 by 3. So we got the equation. Now we need to solve it. So because there is a minus sign over here, I have put it as plus and taken the additive inverse of x. Fine. This is equal to 11 by 3. Now minus x is equal to 11 by 3 minus minus 8. So minus and minus will give you a plus. So finally we are getting 35 by 3 as a value of minus x. We need to find the value of x. So that is minus 35 by 3. Now I have made a slight change in the question. From which number should minus 8 be subtracted to get 11 by 3? Okay. Now let us see how we can do this particular sum. The unknown number is taken as x. So now from x we are subtracting minus 8. So x minus minus 8. Be very clear with this step. It is not x minus 8. We are subtracting minus 8 from x. So it is x minus minus 8 is equal to 11 by 3. So minus into minus is a plus. X is equal to what should be subtracted from 1 by 4 minus 2 by 7 in order to get 13 by 2. So here you have got two calculations. First we need to find this and then we need to find the unknown number that is to be subtracted. Okay. But before we proceed with the calculation, let us write down the steps properly. So we will take x as the number that is to be subtracted. Now x has to be subtracted from what? It has to be subtracted from this. So 1 by 4 minus 2 by 7 minus x should give you 13 by 2. Right? Now let us see how we can solve this particular equation in order to find the value of x. The required steps have been written here. 1 by 4 minus 2 by 7, the answer to which is minus 1 by 28 has been found first. And then we have taken the additive inverse of x, thus giving the statement minus 1 by 28 plus minus x is equal to 13 by 2. From that equation, we have transposed x to one side and the numbers to the other side, thus solving x to be minus 183 by 28. These are a few word problems that you will come across when you are studying the subtraction of rational numbers. So make sure that you are very clear about which number is subtracted from which number. Okay, that makes all the difference to the answer. So now you will also get a few sums that involve both addition as well as subtraction. So let us do two sums of those kind and then move on to the properties of subtraction. In certain problems, you will be given multiple rational numbers in this form. We have to add some of them, we have to subtract some of them, etc. etc. So I have written down a few steps that will make it easier for you to do these kind of sums, at least when you are starting with. Once you are comfortable, you are really comfortable with rational numbers, you don't need to follow all this method. You can just randomly start from the fourth step and do the sum. But these steps, the first three steps, are intended to make it easier for you when you start doing these kind of sums. So the first one is, whenever you are having a rational number, please bring it down to the lowest form if possible. Okay, identify the rational number which is not in the lowest form and bring it down to the lowest form. So I have made a small change in the order of steps because I find this order of steps is easier. Write the additive inverse and then group the numbers having the same denominator and solving them. Okay, so in the previous slide, or it just, when I was explaining the first point, you must have noticed that The second point was written as the third one and the third one was written as the second one. But it is always better to follow in this way. First, convert the rational numbers into the lowest form if possible. Then write the additive inverses wherever required, wherever there is a subtraction sign. Then group the numbers having the same denominator and solve them. Okay, for example, in this case, instead of 7 by 20, suppose you had 7 by 10. Here you have minus 1 by 10. So, additive inverse as plus minus 1 by 10. Group 7 by 10 and plus minus 1 by 10 and solve them in order to get 6 by 10. So, such kind of simple manipulations will make the calculations much easier, especially when you are dealing with larger numbers. So, now let us apply these 4 methods, the last one being taking the common LCM and find the answer for this particular sum so that you get a clear understanding of which all steps are to be followed in which all sums. Look at the sum. I have done the first few steps. I have not completed the sum. So let us see how to proceed. This was the question. So you can see that none of the rational numbers can be simplified further. So they are already in the lowest form. Now I will see whether I need to put additive inverse anywhere. So here there is a minus sign. So I have written the additive inverse. It's plus minus 1 by 10. Then I check for common denominators. So when I am checking 7 by 10 and minus 1 by 10 has got the same denominator, I am grouping them and I am getting 6 by 10 over here. Correct? Now, when you look at these numbers, you can see that 6 by 10 is not in the lowest form. So, I will be converting 6 by 10 into its lowest form and rewriting the equation as minus 12 by 5 plus 6 by 10. I can write it as 3 by 5. Fine. Plus 3 by 14 plus 1 by 7. Okay, now you can see that there is a minus 12 by 5 and 3 by 5 having the same denominator. So, I will get minus 9 by 5 plus 3 by 14 plus 1 by 7. Now, everything is in the lowest form. Additive inverse has already been taken. I cannot group any more numbers because none of them have the same denominators. Now, I will take the LCM of all the denominators, convert each of the rational numbers into a rational number with the same denominator and solve. So, here you can see that the denominator is a 70 and in the numerator you will get minus 9 into 14, 3 into 5, 1 into 10 because we are converting each of the rational numbers into a rational number with the denominator 70. Solving, you will get minus 93 by 70. We have 3 numbers, 5 by 12, minus 5 by 18, minus 7 by 28. So, let us start. The first one, see if any of the rational numbers can be reduced to the lowest form. So, 7 by 28 can be reduced to 1 by 4. Fine. Now, after that, we need to take the additive inverse wherever it is possible. So, there are 2 subtraction signs. So, I will be taking the additive inverse as plus minus 5 by 18 and plus minus 1 by 4. After that, I will take the common LCM of the denominator, which is 36. Now, substituting 36 as the denominator and converting each of the rational number to its equivalent rational number with the denominator of 36, I am getting the numerators in this way. So, I will be getting minus 1 by 9. I hope you are clear with all the problems in subtraction that we have done today. Now, let us move on to the properties of subtraction of rational numbers. Similar to addition, we first start with closure property. So, whenever you are subtracting 2 rational numbers, will we always get a rational number? Yes, whenever we are subtracting 2 rational numbers, our answer will always be a rational number. So, we can say that rational numbers are closed under subtraction. Okay, so that is the closure property. Now, the second one is the commutative property. Now, I don't even have to explain to you. You know that 2 minus 3 is not the same as 3 minus 2. Correct? So, the subtraction of rational numbers is not commutative. In certain cases, it could be commutative. But for example, 1 minus 1. Either way you subtract, you will get a 0. So, in certain cases, it is commutative. In general, the subtraction of rational numbers is not commutative. For the same reason, it is not associative also. Suppose you have something like 2 minus 3 minus 1 by 3 and 2 minus 3 minus 1 by 3. Okay, let us see what we are getting for the LHS and the RHS. Here you can see that you are getting two different answers when you are applying the associative property. So, the subtraction of rational numbers is not associative either. Now, we need to find what is the subtractive or the identity for subtraction. So, just like in the case of addition, you know that the additive identity is a 0. So, in the case of subtraction, the identity will be 0 again, because when we are subtracting 0 from any rational number, we get back the same rational number. Okay, so now we are done with the properties of subtraction. I know I just rushed through the properties. The reason is because very clearly I have explained what each property means in the case of addition. So we just need to check whether it is applicable in the case of subtraction. So closure property is applicable, but commutative and associative, they are not applicable, and the identity for subtraction is a 0.